welcome everyone to the class of marketing research and analysis. So, we are coming to an end towards this course of this course. In the last class we were discussing about the confirmatory factor analysis, in which we said that it is nothing but a measurement model, right. So, where the researcher tries to check whether the constructs used in a model are fitting or not fitting. Okay. So, but as you know that the CFA was a non-directional, or there was no direction provided, rather it was a covariance model, right, where you had a double headed arrow towards each construct, right. That means each construct was connected to the other through a double headed arrow, right. But we were not measuring any relationship in there directly. So, today we will talk about the next part of the next part, which is called the structural equation modeling, or we say here this is called the path analysis, or sometimes which is also called as a structural model. So, as from the name structural, so we say it structural equation, right. So, what it says, a structural model, as you have seen in the in the measurement model. So, you had just a relationship, a covariance relationship, right. So, but here we are talking that this relationship is directional. So, we know that A and B are related in this way, right. So, what is structural equation modeling? It is a procedure for estimating a series of dependence relationships among a set of concepts or constructs represented by multiple measured variables and incorporated into an integrated model. Now, let us see this model, right. So, this model, for example, we say that equity, traditional and stylish, these three are related, right, and each construct has got some number of indicators. So, equity has got liking, buying again or buy again, recommend, right. So, this is the equity of a brand. So, whether people like it, whether they would buy it again, whether they would recommend to others. Now, what is this traditional construct? Now, this says whether the what is the prestige symbol attached with the brand, how big is the brand, how reliable it is. Stylish is another construct which says sophisticated, stylish and adult like, that means would people feel it is childish or adult like, right. So, these three are the constructs that are related, right. So, we are saying okay, these two, traditional and stylish, are affecting the equity of a particular brand or product, right. So, this kind of a relationship structure is what we are explaining in a structural equation modeling. So, there is a clear cut path, you see, but these two being independent variables, or we say exogenous constructs. So, this is called the dependent variable, or you may understand, or in SEM we call it as the endogenous construct. Okay. These two are called my independent in regression or my exogenous constructs. So, these exogenous constructs, they are correlated to each other and they impact the equity, and that is the final result. Okay. In many instances, market researchers must answer a set of interrelated questions. You see how important they are. For example, a service provider like Uber, right, will be interested in the following questions. What variables determine service quality, right? How does service quality influence service attitude and service satisfaction? So, is there any relationship between quality of service and the attitudes towards the service and the satisfaction towards the service? How does satisfaction with the service result in patronage or loyalty, right, whether people would come again and again? How does attitude towards the service combine with other variables to affect intention to patronize the service? So, these are some relationships. So, these complicated relationships cannot be done through a linear regression, okay, because in the linear regression there is only one directional, but here we have multiple relationships. So, that is why structural equation modeling comes into a becomes very handy. Okay. So, to answer such questions in a unified and integrated manner, the researcher must use structural equation modeling. Okay. SEM can help us to assess the measurement properties which you did through the measurement model, and then test the proposed theoretical relationships. Now, the proposed relationship you see here, that you are saying traditional image affects the equity and stylish image also affects the equity. So, this is a relationship that you have depicted. Okay. SEM versus other multivariate techniques. It is a representation of constructs, you have seen that, right, as unobservable or latent constructs, right, in dependence relationships. Estimation of multiple and interrelated dependence relationships incorporated in an integrated manner. Yes. So, there is a lot of relationships, for example, A is related to B, let us say, or A and C is related to B, and then B is related to D. So, this is a very complicated and unique relationship, right. Explanation of the covariance, right, between among the observed variables. SCM seeks to represent hypothesis about the mean variance and covariance of the observed data in terms of a number of structural parameters defined by the hypothesized. So, it says a number of relationships can exist in between. So, maybe you may say that, well, it is not B does not affect D only, A directly affects D also, right. So, we can see SCM is also known by other names such as covariance structure analysis, latent variable analysis, and causal modeling. Okay. So, but SCM has become a very famous name nowadays. What is the role of theory? The foundation of SCM is theory, right. This is the most important word when you talk about SCM, because SCM is like a priori. You have to first find a model, you have to first think about a model, and then you have to test the model. So, you cannot change anything after you have hypothesize the model, that is not permissible in SCM. So, that is why your model has to come from some theory, right. That is why you say ki, well, I believe this is what the structure should look, and then this should be the outcome. If it is not, it does not work that way, then your thinking is wrong, or that means the theory that you have used may be not proper, right. So, that is why a sound theory is very important to develop SCM. A theory serves as a conceptual foundation for developing a model, right. So, you do not go by any gut feeling, or just sometimes people what they do, they if A and B and C are related, and suppose this does not work out, then they will say let us try something else, put a D here and see the relationship. No, this is not to be done like this. You do not do anything on a gutsy feeling, or just to try out something different. No, it is already you have to give the model beforehand and say ki, this is what I believe, and now if it does not come, then maybe I have to go add some more variables or delete some variables and check, but that also on basis of the theory, right, on basis of literature. Theory is defined as a conceptual scheme based on foundation statements that are assumed to be true, right. It is very important that SCM model may be based on theory, because all relationships must be specified before. So, this is what is a highlighting word, before the SCM model can be estimated. You do not do it after, which many people try to do a lot of iterations, but that is a wrong thing. You should not, that is against the spirit. You may get a good model, an improved model, but then there is no theory behind it. You are just doing a lot of probabilities and permutation and combination and iterations to check whether model value is improving, and since it is only a mathematical number, so it might improve, but then the spirit of the whole exercise is lost, because you have not come out with a proper understanding why this should happen, and you have not developed a theory, right. Theory is needed to specify the relationships, right, in both measurement and structural models, modifications to the proposed relationships, and many other aspects of estimating a model. This is why you see it helps in establishing a causation. Why SCM is little more complex? It is because you have to specify the theory, on basis of the theory you build the model, and after building the model you test it, okay. And when you test it, you are not allowed to go back again, right. Go back in the sense you are not allowed to play with the model, you are not allowed to do that, because it has to be based on a sound understanding, okay. So, that is why if something goes wrong, maybe you have to do the study entirely, or maybe add a completely new variable according to logic, or delete something, and maybe your data size also has to change, okay. So, a model is a representation of a theory, nothing more than that. A theory can be thought of as a systematic set of relationships providing a consistent and comprehensive explanation of a phenomena, right, why it is occurring or what affects what. So, this relationship has to be understood, okay. SCM model consists of the measurement model and the structural model. So, we have talked about the measurement model earlier. So, we just wanted to test whether the model is fit or not, that means all the constructs are linked to each other or not. And in the structural model we are saying there exists a proper relationship, that means a direction is there, that means A affects B. It does not mean that A and B both are dyadic or both affect each other, no, A affects B, it is very clear, and that means it has come from theory. For example, you see now exam performance is affected by what? Now hard work or let us say exam performance is affected by hard work, okay, hard work, and let us say I am taking one more construct, hard work and let us say IQ. Okay. Now, hard work depends on two more variables, let us say one is let us say your financial condition of your family, right, and your ability to concentrate, right. So, when you do such a relationship, it is already we understand it, right, why we are doing it. Okay. The measurement model depicts how the observed variables represent the constructs, that is all, nothing more than that. A structural model, this is the what we are talking about, shows how the constructs are interrelated to each other, often with multiple dependence relationships. So, this is not one relationship as you see here, right, it is a multiple dependence relationship. So, multiple dependency, hard work is again performance is affected by hard work and IQ, and hard work is again affected by finance and maybe the condition of the house, and IQ may be affected by something like which kind of environment you were born in and what is your parents' education, could be, I am just giving a guess, right. A model is portrayed in a graphical form known as a path diagram. So, this entire thing is called a path diagram. Okay. Now, look at this, this is the measurement model. So, every construct was related to itself and the indicators are here, but here there is no proper direction as in this one. You see, if you can see this kind of arrows, the curved two edged arrows, double edged arrows, it is only present here, right, this case. Why? Because these two are independent variables and we are saying that they both affect each other. But look at this case now. So, reading and writing ability is affecting the maths performance of a student, and maths effect is then affecting the entire science. So, if somebody is good at maths, he will be good at science, we are saying. So, the science mark depends on how good you are in maths, and maths mark depends on how good you are in reading and writing. Okay. Exogenous is the, as I said earlier, latent multi item equivalent of an independent variable, right. And exogenous construct is determined by factors outside of the model and cannot be explained by any other construct or variable, right. So, it is like an independent variable. Endogenous is the latent multi item equivalent of a dependent variable. It is determined by constructs or variable within the model, and it is thus it is dependent on other constructs. You see, this is a exogenous construct, right, which has got several variables, and this is a endogenous construct. Why this is endogenous? Because this is the dependent. So, this depends on the value of this. Okay. Only thing is this is a construct, latent construct, both are latent constructs. Okay. A dependence relationship is shown by straight arrows. So, this is something like this. The arrows flows from independent to the dependent measured variable or latent construct. A correlation relationship, or also called covariance, specifies a simple correlation between exogenous. So, exogenous constructs means which these are the two independent 1 and 2. So, we will say this is a covariance relationship. So, let us see this. So, this is the exogenous construct, this is the endogenous construct, and these are 3, and this is how the relationship goes. And this is how the correlation relationship between two exogenous constructs. This was exogenous and endogenous, this is exogenous and exogenous. So, this is a double headed arrow. Okay. 6 stages in SCM. So, what are the 6 stages? The first is the measurement model 1 to 4. So, what is this 1 to 4? Defining individual constructs, develop the overall measurement model, design a study to produce empirical results to understand whether the model is a fit model or not, and to first then check the validity through a discriminant validity, convergent validity, all these, right. So, this stages 1 to 4, right, 1 to 4, right, is called my measurement model. Okay. Measurement model. These two are my structural model. So, today we will be discussing on only these two, right, because earlier in the last lecture we had already covered this first 4. Okay. So, in the stage 5, this stage, right, it involves specifying the structural model by assigning the relationships from one construct to another based on the proposed theoretical model. So, on the basis of the proposed theoretical model, you are now trying to specify a relationship. Structural model specification focuses on adding single headed directional arrows to represent the structural hypothesis. Okay. So, you must have your hypothesis in your research work. So, you are trying to see by putting some directional arrows, right, in the researcher's model, but the arrows will be based only on sound theory. I am repeating it again and again, do not just put any arrow from anywhere to anywhere, it has to come from some theoretical perspective. In other words, the researcher identifies the dependence relationships that are hypothesized to exist among the constructs. Each hypothesis represents a specific relationship. So, A, B, C for example, so A affects B, that is one hypothesis, B affects C another hypothesis, A affects C another hypothesis. So, you have a number of hypotheses. Performance in exam depends on hard work and concentration. Okay. This is what the example. Concentration depends upon how size of the house, how big a size you have, a small, very small house 8 by 8 feet, or a you have a house with 10 rooms where you can freely sit, and a family condition, right, whether somebody's father is a there is a lot of fighting between the parents or something. So, that also affects my concentration. After that is done, after you have done that model, then you have to assess the structural model validity. So, the final stage involves efforts to test the validity of the structural model and its corresponding hypothesized theoretical relationships. Only when the measurement model is validated, the first point, the 1 to 4, right, and achieves acceptable model fit, then we can test the structural relationships. And remember one more thing, I have not mentioned it here, always remember the model fit values that you will get, right. You should always compare the model fit values of the CFA model, the measurement model, and the structural model, right, and your structural model fitness should be more than the measurement model fitness. Then you can always say that you have depicted a relationship or build a model on a very sound theoretical perspective. Okay. Competitive fit. The primary objective is to ensure that the proposed model not only has acceptable model fit, but it performs better than some alternative model. Suppose for example, you have alternative models, that means what, or nested models. Now, I have a model in which if I feel one of the variables is creating a weakness to the entire model, right. So, we may delete one of the relationships or we may add a new relationships on basis of some theoretical perspective. Let us go back to this case. So, let us say I am saying hard work and concentration, performance in exam. Now, I feel this model is not adequate, I want to add something more, maybe if I add a new variable it will be better. What is the new variable? Performance in exam depends on hard work, concentration and IQ. So, which I had missed earlier. By adding this, if my model improves, which theoretically is also true, if it improves, then I can say, well, I had missed on a variable, right. So, this is what needs to be checked. Then, so when you add a new model, this is called when you add a variable or you delete a variable, right, it is called the new model is called a nested model, or sometimes we call it a rival model. Okay. So, this nested model needs to be checked, nested model. Okay. Comparing. So, alternative models are tested by comparing models of similar complexity yet representing varying theoretical relationships. A common approach is through nested models. Okay. Very clear. That means you had a model, now by adding or deleting a variable, whatever change comes, that new model is called a nested model. So, you compare the base model or the existing the first model with this new alternate model and see which one is performing better, and the one which is performing better you need to accept that. Okay. Testing structural relationship. The researcher also must examine the individual parameter estimates that represent each specific hypothesis. A theoretical model is considered valid to the extent that the parameter estimates are statistically significant and in the predicted direction. That means, the direction also should be as you think and it should be statistically significant. They are greater than 0 for a positive relationship and less than 0 for a negative relationship. Now, how to do this? Let us see how to conduct this SCM in SPSS, not in SPS actually, we will conduct it in SPSS today is giving this facility, or we use a software called Amos, or some people use Lizrel, okay, but I am using Amos. Okay. So, I will be using this one. So, let us open this file, this is the file, right. This is just a file. How to do this is by now you know how to draw, right. So, there are several variables, in fact this explanation, this example is given later on also. So, I will show that, just have a look at it. Now, in the last class when you were doing the last lecture, there was a 2 headed arrows to be connecting all the different constructs, correct, 2 headed arrows, but here only these two have a 2 headed arrow and other there is a clear relationship, right. So, let us see, now let us go back. This study is the same example that we had done in the last lecture. So, we had covered this in CFA. So, the example is as follows: ABC industry deals in finished products made by papers. Okay. They employ 1000 workers, and there is a problem of attracting and keeping the productive employee. The cost of replacing and retaining employees are high. ABC management wants to understand the factors that contribute to employee retention. The company wants to test a measurement model that affects the employee attitude and behavior about remaining with ABC, and it found that there are 5 different constructs. Okay. So, this was the same case that you had done in the last lecture. The case now, only thing that changes here is that now we will create a directional relationship among the different constructs, and we will create some hypothesis out of it. Okay. Now, look at this. So, now it is no more a measurement model, now it is a structural model. Okay. Why it is a structural model? Structural model because now clear cut relationships are there. So, environmental perception we say is affects job satisfaction, and attitude towards co-workers also affects job satisfaction. But environmental perception affects organizational commitment also. Attitude towards co-workers also affects organizational commitment. Job satisfaction affects organizational commitment, and organizational commitment and job satisfaction both also affect the staying intention in a firm, right. So, this is the proposed model. Now, how do you do? Let us just have a look at it, although I will be doing it for you. So, this is the CFA model. First, all the different constructs are there with their related variables. So, you can see this is a reflective construct, right. So, now we are drawing a covariance structure, and we will now we will connect these models and we will run it, right. So, these things I will show you with the example now. Now, let us go back to the example. So, here you see what we have done. So, we have done the same thing here. Now, the data, you know how to connect with the data, let me show you so that you do not get in a problem. So, I have the file, you go to the file, go to the data files, right. So, where is your data file? You see, for example, this is my data file, right. So, this is my data file, open, okay, right. Now, when you want to take the variables, whichever variables you want to take, variables in data set. So, all the variables are okay, you can take it like this, I am just showing you. So, you can just drag something JS1 for example, and you can take it here, right. So, this will come here. So, you can make this when you do, you can just drag and drop into the A, and other things, how you know how to give the name to the unobserved variables, just go there and click the unobserved variable, all the unobserved variables, these are the error terms, this will automatically be there, right. Now let us run this model and see here what is the condition. So, when we run this condition, before that you have to remember this, you have to, this is a maximum likelihood method, and output we have given this some of the things which we require. So, indirect and direct effects, minimization history, standard estimates, multiple correlation and modification indices. Okay. Now, we have run and let us see the output. So, when you look at this output, the output says that the model is 1.568. Now, if you remember, we had said that anything below 3 is acceptable good, right. Below 2 the chi-square by degree of freedom is very good, above 3 and below 5 moderate, above 5 not so good, above 10 not acceptable. Okay. And let us see now, since we are not only interested in the model fit, now in the CFA what were you doing? You were checking this and then checking some of the parameters like the GFI, the IFI, the CFI, and we are trying to see whether the model, all these indices are good or not, right. So, they should be above 0.9 and that is correct, right. But in this case now we are not only interested in that, we are interested in looking at the relationships. So, we will go to the estimates. Now, look at it. So, now you see environmental protection affects job satisfaction. So, this was one of the hypotheses. Let us see the diagram. Environmental protection affects job satisfaction, environmental protection affects organizational commitment, attitude affects organizational commitment. Let us see this. Okay. So, environmental protection affects job satisfaction, is it significant or not? Now, look at this. Now, this is the estimate, this is my standard error, if you divide these two you will get this, right, and is this significant? Yes, it is significant, this 3 dots means it is significant at a 0.001 level, right. Is this significant? Second one, attitude affects job satisfaction? No, it is not. Why? Because it is above the 0.001 level or whatever you are taking 0.05 or something, right. So, this is much above. So, the null hypothesis you cannot reject it now, right. Is this is this relationship significant? No. But these two in between, attitude of co-workers affecting the organizational commitment and environmental protection affects the organizational commitment, these two are again significant. This is also significant, although it is a poor value. If you take 0.001, not significant, but if you take 0.01 or 0.05 let us say, then it is significant, right. So, you can develop, you can check this, right. So, by checking this, now you can write in your results, well, that we found that this model is affecting these relationships are positively, these are positively related. That means what? Environmental effects, protection affects job satisfaction, but and attitude towards co-workers also affects the organizational commitment, all these things, but this one you will say no, attitude towards co-workers did not yield a result that it affects the job satisfaction positively, right. So, this is what you write in the hypothesis. Okay. Now, let us go back. So, this is what you have done, right. So, okay. So, this is what I was saying. So, go to the output and you take this, and this is what you have got in the model fit values, okay. And you see, so now this is the calculating the path estimates, it is called calculating the path estimates. So, go to AMMO's output and check the regression weights. So, we have checked the regression weights exactly this and standardized regression weights. As we can see that hypothesis towards attitude towards co-workers and job satisfaction is not significant. This we are talking about this one, right, this one. As well as hypothesis that job satisfaction has effect on organizational commitment, which one? Job satisfaction on organizational commitment. So, where is it? Job satisfaction this one, right, 0.106, right, has effect on is also non-significant and the rest are significant, right. So, this is how you write the about the path estimates, and you say okay, this was my hypothesis and my hypothesis has been found to be true or not true, right. So, this is what we have discussed today. So, we have understood what is the structural model, why it is called structural model, and what are the things that should keep in mind while developing a structural model, and finally, how do you interpret the structural model. In the next lecture, I will be talking on something more detail in the structural model itself, right, and we will continue from there. Thank you so much.